Good day, matriculants, incorporating students who are reading their metric, um, geography teachers, and people who are curious in learning more about geography. Today, we are going to be discussing some questions under mid-latitude cyclones. Okay, yeah, so today we're going to be looking at questions through our question papers, guys. Question papers are so important to improve your answering skills, to improve your answering, um, and also to know your knowledge better, so that you can know where you seek knowledge and so on. So by practicing these kind of question papers is going to help us a lot, guys. Yes. So now we're doing mid-latitude cyclones. Okay. Yes, as you can see also our annexure. Yes, so we have annexure, a question paper, and answering sheet. Okay. Yes. So let's go straight into the questions, guys. Okay. Question 1.3 says the figure 1.3 is a three-dimensional representation of a mid-latitude cyclone over the United States of America. Okay. Yes. So this is 2017 question paper, Feb and March. Yes. So it's past question papers, March and exam are mostly used during your trials and then also your finals. So this kind of a question might appear during your final examination or some similar to it. Okay. Yes. So the very first question says name front A and B. Okay. Yes, looking at our lecture, we can see it in our lecture. That is a mid-latitude cyclone, right? Yes, it's given. That's a mid-latitude cyclone. Yes. Okay. So question 1.3. 1.3. Okay. Yes. So question 1.3 says figure on the annexure is a three-dimensional representation of a mid-latitude cyclone over the United States of America. 1.3.1. Okay. So 1.3.1, name front A and B. Looking at our annexure, front A, name front A and front B. It's given. Front A is there? Okay. They are confusing you. You can see they are making a question trickier for you to think twice. Yes, they are really looking for your understanding. You can see front A. The front A, you can see it's a cold front, right? Yes. And front B is a warm front. But in front A, which is a cold front, they put warm, which shows or illustrates a warm sector just behind front B. You see, they're playing with your minds. So front A, you can see it's a cold front, and front B is the warm front. So be careful when answering these questions, guys. It's a cold front. In front B, it's a warm. It's a warm front. It's a warm front. 1.3.2 says, in what stage of development is this mid-latitude cyclone? Okay, they're asking you in what stage development is this mid-latitude cyclone. Okay, In what stage? Okay, for further explanations, going back just a little bit behind to cold front and warm front, you can see also that how you can see that A is a cold front and B is a warm front. A cold front, this is whereby a front can say it has a triangle like. Cold front has a triangle like, as I explained in our lessons. Okay, as a cold front has a triangle like, so we have to differentiate them. And the warm front, I can say it's okay. This is a warm front. It has a siren like, a siren in police cars, ambulances and so on. It's round like, yeah. So it's kind of like round. That's a warm front. Cold front, triangle like, yes. Okay, 1.3 point. Yes, in what stage of development in this? Okay, there are 3 stages of mid-latitude cyclones. We have initial stage, we have mature stage, and we have occluded stage. So the characteristics of initial stage, what happens, mature stage, what happens, and occluded stage, what happens. Okay, this mid-latitude cyclone is in mature stage. You see, is in mature stage. Is in mature stage. This method is in mature stage. Why I'm saying is mature stage, although the question didn't say why. Okay, I'm explaining further, guys, by supporting these answers. Okay, in what stage? Yes, is in mature stage. In initial stage, this is whereby the cold winds, which originates from polar front, the polar easterlies, meet the tropical westerlies in 60 degrees south and north of the equator, right? Yes, in those latitude. When they meet, they form a front which is known as polar front. That's the initial stage, and they cause some sort of a bend. So that's initial stage of what happens initially in the formation of a mid-latitude cyclone. So then there is a mature stage begins after initial stage. This is whereby we can see the cold front the cold air became dominant on the ground, right? Yes, on the mature stage, and this is whereby the cyclone begins to move in a clockwise direction in a mature stage, and in mature stage it starts to also move from west to east. Mid-latitude cyclone move from west to east. It starts to move now. This is the reason why I'm saying it's a mature stage. You can see the arrows. That cyclone is moving. So in southern hemisphere it moves in a clockwise direction, and northern hemisphere anti-clockwise. Southern hemisphere clockwise direction, northern hemisphere anti-clockwise. Yes, so that's why I'm saying it's a mature stage. And also we can clearly see the fronts are in or begin to appear in mature stage. That's why I'm saying it's a mature stage, guys. Yes, so 1.3.2 says, give evidence in the diagram to prove that this mid-latitude cyclone occurs in the northern hemisphere, as I've just said, guys. As I've just said, in northern hemisphere it moves in an anti-clockwise direction, and in southern hemisphere it moves in a clockwise direction. That's a mid-latitude cyclone, right? Yes. So the question is give the evidence that to prove music occurs in the northern hemisphere. So yes, it occurs in the northern hemisphere. Why? It moves in an anti-clockwise direction. It moves in an anti-clockwise direction. That's 1.2. Yes. So in northern hemisphere, mid-latitude cyclones, they move in an anti-clockwise direction, and then in southern hemisphere, mid-latitude cyclones move in clockwise direction. Yes, that's it. So yes. So this is 1.3, by the way. So sorry. 1.3.3. Yes. 1.3.3. So let's go to 1.3.4. 1.3.4. So 1.3.4 says that give a reason why front B is associated with a greater rainfall extent than front A. Yes. So basically they're trying to say that front B, which is a warm front, has a is associated with the greater rainfall extent than cold front, which is front A. Yes. So let's support that. Okay. Front B, is a warm front, right? Yes, it's a warm front. So a warm front, yes. So for question number 4, yes. So let's give a reason, guys. As I said, a warm front has some warm air. Warm air has much ability to rise. Warm air has humidity, has high humidity than cold air or cool air. So, and therefore, warm air rises, causing or leading to rainfall. Right? Yes. So, in the warm front, warm air rises. That's your first point. How many points? They said 1. Warm air rises. That's number 1. Warm air rises. Yes, warm air rises. Okay, you can say leading to formation of the formation of nimbostratus clouds. Nimbostratus clouds. 1. This is a mark. Okay, let me just write everything in my mind. Okay, warm air rises leading to the formation of nimbostratus. Okay, and also you can also say nimbostratus clouds. Thus clouds have a very great horizontal extent, resulting in nimbostratus clouds have a very long, great horizontal extent, resulting in large rainfall cover. And say that's number 2. So you are going to choose which one you like in terms of this question. Okay, so let me explain further. Okay, give a reason why front B. Okay, yes. So why front, the warm front is the one that is said to be resulting in greater rainfall extent, right? Yes. So that's the reason. The very first reason I said warm air rises, that's a mark. Okay, the warm air rises, leading to formation of, this is the other point I can say, nimbostratus clouds have a very great extent of resulting in rainfall, large rainfall cover. Yes. Yes, again, this one, very great horizontal extent resulting in large rainfall cover. Yes, that's it. So those are the important points, right? Yes. So basically, as I said, warm air rises, it has humidity leading to the formation of nimbostratus clouds under the warm front. We know that we have, okay, just behind the warm front, as you saw in our annexure, that behind the warm front or in the warm sector, we have the clouds which are called nimbostratus clouds. But in cold front, or just below or behind the cold front, we have clouds which are called cumulonimbus clouds. Right? Yes. So behind the cold front, we have cumulonimbus clouds, and behind the warm front, we have nimbostratus clouds. That is why I'm saying, and I'm supporting this statement of this question, right? Yes. So nimbostratus clouds have a large, very great horizontal extent resulting, yes. So this means that nimbostratus clouds are very, very long. They cover a long area, like a long, they are long. These are nimbostratus clouds are long, and therefore when it's raining, the rain is going to affect or fall in large scale in the land, right? In large scale in the land. That's why. And these are nimbostratus. And yes, that's the answer. So I'm just explaining further so that you don't confuse. Then cumulonimbus clouds are big, are very, very big, are the ones that there's a lot of impact, right? A lot of rainfall and so on. But they are just long. They are long in terms of vertically long, right? Vertically long. They are long. They are long. And nimbostratus, yes, are long in terms of horizontal. You can see they're very, very long in terms of horizontal. So the horizontal extent is going to result rainfall in large scale. So we have cumulonimbus clouds. Sorry, cumulonimbus in cold front, right? In cold. Okay, yes. So nimbostratus clouds have a very great horizontal extent resulting in large rainfall cover. So if in the sky Nimbostratus clouds have a very long horizontal size. That means, or they can result in a wide range, in a very wide range. The rain can affect a very large scale in the at surface in the land, a very large scale. But the cumulonimbus clouds can result in a smaller scale, but it has much heavy rainfalls and very negative and harsh effects, cumulus clouds. But this one, the reason why, even the question says, give a reason why front B is associated with a greater rainfall extent. That's why. Because the nimbostratus clouds have a large or a great horizontal extent. You can see in terms of horizontal size, it's very longer. You can see, and therefore it's going to affect a large rainfall cover or cause a large rainfall cover in the surface. You can see, and also this side. But cumulus clouds, yes, they are also big. Cumulus clouds, they are so big. But in terms of vertical height, they are so long. They are long in terms of vertical height. In terms of horizontal height, nimbostratus are longer. Yes, and therefore causing. That's why it's said to be as a or associated with a greater rainfall extent than front A, which is called front, and we receive or we find cumulonimbus clouds in cold front or behind cold front in a cold sector, and we find nimbostratus clouds behind a warm front in a warm sector, right? Yes. So that's why, yes, guys, I was just explaining that. As you can see, vertically it's long, but this one horizontal is long. That's why it's resulting a large rainfall cover in the land. But also this one, but not as much as nimbostratus. But this one has heavy, very heavy rainfalls, heavy. But this one covers a large scale in the land. I think I've nailed that, guys. I think you understand now, because I don't like it when you don't understand, right? Okay. I think we should head to 1.3.5. Okay, question 1.3.5. Question 1.3.5 says, describe likely weather conditions associated with the cloud type at front A. So now we are going to write down weather conditions under a cold front. So as already assumed that front A is a cold front, so they're asking weather conditions. Okay. When the conditions under one front, they said 2, so that means 2 times 2, 4. So 2 points each, 2 marks, so 4. Yes. So I'm not going to only just write 2 points. I'm going to write further points, guys. I'm going to explain further, as I said. Okay. The very first one, weather conditions. It's very cold. It's very cold. That's number one. Point number two. I can also say here low temperatures, very low. Let me just not say low. Let me just say very low temperatures. Very low temperatures, very cold. Torrential rainfall. which is heavy rainfall. Very heavy rainfall. Torrential rainfall. Very heavy rainfall. I can say very. This is very heavy rainfall, right? Yes. So let me go further. Under cold front, we also know that we have your can also result in hail. In hail, yes, hail or some kind of snow. Yes, I can also say snow can result in snow, and also thunderstorms. Thunderstorms, cumulonimbus clouds result in thunderstorms. Generally. 5. Lightnings, cumulonimbus clouds result in lightnings. And lightnings. Point number 6, I can also say cumulonimbus clouds. Weather conditions. Full. You can say full forecast or full skies with clouds. Full skies with cumulonimbus clouds. I'm not writing straight even. Okay, so that was 1 point. So these are the conditions under a cold front. Just behind a cold front, they are asking for weather conditions in cold sector. Yes, so torrential rainfall, it was brought by this. Let me look for the other color. It was brought by this cumulonimbus clouds. Many factors were brought by or were resulted by cumulonimbus clouds. So cumulonimbus clouds has resulted in lightnings, in thunderstorms, in torrential rainfall. Yes. So that's it. So two each. Yes. So that's it. So they said you're going to get 4. So let's count. Yeah. So choose which one you can choose when you are facing these kind of questions during your examinations. Okay. So we know it's very, very cold, very low temperatures. It's winter. Mid-latitude cyclones approaches South Africa or hit Cape Town in winter. Let me show you. Let me say this is South Africa. This is South Africa. Mid-latitude cyclone. Your cold front. There's mid-lights moving from west to east. This is the cold front. This is the cold front. Yes, hitting the tip of South Africa, which is going to affect this tip, the southern Western Cape, the southern west part of South Africa. This is maybe Cape Town. So Cape Town, that's why it's always receives winter rainfall. Yes, that's it. And these are the mid-latitude regions. These are mid-latitude regions. And these are tropical regions. These are tropical regions. Yes, if you can visit the past lessons that I've made about mid-latitude cyclones, you you can understand better, right? Yes. um yes, so let's go straight to, oh yes, it's winter. So it occurs in winter, so it's very cold. As also these mid-latitude cyclones bring cold weather conditions and very low temperatures in winter, because the equator is moved away from South Africa. It moved upwards, and these um, the 30 degrees south has moved upwards. 30 degrees south has moved upwards. Yes, equator has moved away. Yes, therefore experiencing winter. That's it, guys. Okay, let's go to 1.3.6. 1.3.6, 1.3.6, which is the last question. Discuss two expected weather changes that could occur when the mid-latitude cyclones reaches the occlusion stage. As I've said to you guys, that there are three stages of mid-latitude cyclone. One, initial stage. The second one is mature stage, which we've asked about on our questions. On one of our questions, the last one is occlusion stage, right? One, initial stage. Two, mature stage. The last one is occluded stage, which the question is asking us about. Yes. So as I've said to you, that in initial stage, that in initial, which is 1, 2, mature, initial stage, mature stage, and occlusion stage, which the question is asking us about. These are the stages of a mid-latitude cyclone. In initial stage, I've explained that two hemispheres meet, the polar easterlies, which are very, very cold, dry, and the wester, the tropical westerlies are going to meet these. Let me just draw here. Let's say this is 60 degrees. This is 30 degrees. These are the latitudes, guys. These are the poles, 90 degrees, right? And we're going to have these polar easterlies meeting the tropical westerlies. And therefore, as I've said, this is part of initial stage. They're going to cause a bend here. The warm air is going to be forced to rise by the polar easterlies. To rise, and then after it has risen, it's going to form cumulonimbus clouds. And therefore, the system is going to begin to start to move in either clockwise direction or anti-clockwise direction, depending on the sphere, the southern hemisphere or northern hemisphere, right? Yes. So we're meeting the mature stage now. It starts to move, and also it spreads from west to east, moving from west to east. Okay, that's mature stage. And then occlusion stage now. So the question is, discuss in occlusion stage. This is whereby a warm front is taking over a cold front, and also a cold front is taking over a warm front. I've explained this stage on my lesson about occlusion stage, which are under mid-latitude cyclones. Okay, yes. So this is occlusion stage now, right? Okay. That's occlusion stage. Okay, I think I've explained all of these stages. Discuss two expected weather changes that could occur or result when the mid-latitude cyclone reaches occlusion stage. Yes, easy, easy. So the air temperature on the ground is going to decrease. The air temperature on the ground is going to decrease. It's going to decrease. Yes, that's it. That's number one. Okay, how many? They said two. 2 times 2, 4. So 2 marks each. I should write 2 points, but I'm going to write others. And during the occlusion stage, the temperatures will drop, right? Will decrease. Temperature on the ground going to decrease. And also I can say a pressure will increase. A pressure will increase. This is 1. This is 2. Pressure will increase. Pressure will increase. Wind speed will decrease. Number 3. Wind speed will decrease. Wind speed will decrease. Yes, that's it. Okay, I can write 3. Okay, I've just written 3 points. Let me explain further. During the occlusion stage, this is whereby a cold front has passed or moved away South Africa, right? And passed or affected South Africa, right? Yes. My point number 1, let's refer to it. The air temperature on the ground is going to decrease. The air temperature on the ground is okay. This is whereby in the ground, the cold front is going to be dominant, causing the air temperature to decrease. And this is whereby the cold front has taken over the warm front. There's no much warm air now, right? The cold air is dominant, resulting in the temperature to decrease on the ground. That's why that's point number 1. Point number 2, a pressure will increase. Like this mid-latitude cyclone, it's on its last stage now. It's weaker, right? It's weak now. It's approaching the east side of South Africa, which is warmer, and it became weak and so on, and starting to drop in terms of operations, right? Yes. So a pressure will increase. A pressure will increase, meaning that the high pressure weather condition will be resulted in occlusion. Why? A mid-latitude cyclone is a low pressure system. So when it drops, becomes weaker, high pressure is going to be resulted. Yeah, that's the second one. The third one is wind speed will decrease. A mid-latitude cyclone, as it moves in clockwise direction in southern hemisphere, in clockwise direction, it causes the wind speed to increase, right? It's moving in high speeds, and now it's becoming weaker in the occlusion stage. It's weak on its last stage, and therefore the wind speed will decrease. That's it. Thank you so much, guys, for your time. I wish you see you next time, and I hope you've learned something from my lesson. And please don't forget to subscribe, like, and comment to my video. Thank you so much. See you next time.